Hey Trig class, let's look at this problem from 5.5. So we got a quadratic in form trigonometric equation. What do we mean by quadratic in form? Remember, quadratic equations that you studied in like an algebra class look like that. That's a quadratic equation. And what we're saying is there is something in this equation that's being squared in one term, and it's being just multiplied by a number and added to that squared term in another term. And then there's constants. So it's like, this is like A, this is like B, and this is like C, and then the tangent is like the X. Okay? So how do we solve, how would I solve this problem if it had been 2x squared plus 9x plus 7 equals 0? What I would try, and what I encourage you to try, is factoring. So 2x times x is 2x squared. Now, what two numbers multiplied by 7 could go here and here, or what two numbers that multiply to give me 7 could go here and here, to where the inside-outside combinations would be 9, and that's going to be a 1 and a 7. And if you add these together and you FOIL it back out, you'll get a 2x squared. Outside you'll get a 2x. Inside you'll get a 7x. And last you'll get a 7. And that does give us our expression back. So this is how that thing factors. Oops, I just erased it. All right, well, that's how it works with this. Well, look at what we just said earlier. That x is like the tangent function. So this equation right here would factor to 2 times the tangent of x plus 7 and the tangent of x plus 1. Alright, why did we factor like that for quadratics? Because now we can set each piece equal to 0. This could be set equal to 0, the 2x plus 7, and then the x plus 1 could be set to 0. Well, I'm going to do the same thing here. I'm going to set 2 tangent x plus 7 equal to 0. And I'm also going to set the tangent of x plus 1 is equal to 0. Each one of those factors there are multiplied just like these are multiplied. Each one of those factors gets set equal to 0, and I solve. So here, if I move that 7 over, I'll have a negative 7. And then if I divide away that 2, I'll have a negative 7 halves. And then here I get tangent x equals negative 1. Now this is where it's really important for you to look at your instructions and understand what you're being asked to do. Solve the equation for x in the interval. Use exact solutions where possible. I can find the exact solution to this because this is a special value on the unit circle. I can do tangent equal to negative 1. Give approximate solutions to correct to 4 decimal places when you can't give an exact solution. This is that one. I have no idea the exact value of x that gives me negative 7 halves because it is not one of our special values on our unit circle. You're not going to see negative 3.5 on there anywhere for tangent. But we can find the place where tangent's negative 1. Remember what we said last time. This is where tangent's equal to positive 1 at pi over 4. If we flip that over the x-axis at 3 pi over 4, we're on that same trajectory that we're coming from the origin, but just coming downhill left to right. That's a negative sloping line. Remember, tangent is the slope of the line segments that connect the origin to these points on the circle. Tangent's the slope of that line segment. So that's a negative sloping line with a slope of negative 1. Right? Change in y over change in x. So they're equal but opposite, so the slope is negative 1 there. So 3 pi over 4 is a place where this happens. Alright, we're solving it in 0 to 2 pi. So just like all these tangent solutions, if I go through the origin and come out the other side, the exact same distance, alright, that same linear path, 3 pi over 4 origin, I'll end up at 7 pi over 4. And that also has a slope of negative 1. I'm falling as I go left to right. So that's also got a slope of negative 1. So 7 pi over 4 is also a solution to tangent x equals negative 1. Alright, here's the thing. tangent x equals negative 7 halves. That is not that's not an exact, I'm not going to be able to find that exactly. So what I'm going to have to do here, number one, I'm going to need to use arctangent or inverse tangent to find x. Okay, here's the problem with that though. If you remember from your inverse, the inverse functions, arctangent and arcsine are only defined in quadrants 1 and 4. This is where we find our angles for arcsine and arctangent. They live in there. If it's positive, if they're positive angles, they live in quadrant 1, but negative angles if they live in quadrant 2, because arctangent and arcsine can only give me acute angles, positive from 0 up to pi over 2, and negative angles from 0 down to negative pi over 2. Because this is a negative number, all right, where is tangent negative of these two choices, quadrant 1 and quadrant 4? If I drew a line segment from the origin to the unit circle here, and that's a positive sloping line segment. If I draw a line segment connecting the origin to a point on the unit circle in quadrant 4, that's a negative. This is where tangent is negative. Tangent is negative in quadrant 4. Okay, but what's going to happen is arctangent is going to give me a negative number. It gives me positive numbers in quadrant 1, negative numbers in quadrant 4. Why is that a problem? I only want numbers between 0 and 2 pi. So here's what we're going to do. We're going to use arctangent to find x. Because that number is negative, it's going to give me a negative number. So let's find the number. So I'm just write arctan, open parentheses, negative 7 halves, close parentheses. All right, I get this number. All right, negative 1.2925. All right, this absolutely will not work because it's a negative number. It's not between 0 and 2 pi. All right, we have a negative number here. How do we get a positive number? Remember, we're trying to find where tangent is equal to this number. As long as you're on the same line, the tangent is the slope of that line, right? So as long as I'm on that line, I have the right tangent. So what I'm going to do is I'm going to take that negative angle that they gave me. This is that angle. I'm going to add pi radians, and that's going to give me the angle right here from the positive x-axis to the quadrant 2. That's going to be this second angle that I find. So the second thing we need to do, add pi if x is negative. All right, if x is negative, and it was, I add pi to that. So the first solution that we're looking for, I'm going to call it x1, is approximately equal to negative 1.2925 plus pi. All right, back to Desmos. Let's call that x1. All right, I'm going to write what I just said. Let's call that A for angle. All right, I'm going to say x1, the first thing that I'm looking for, the first solution, is equal to that angle plus pi. And I get 1.8491. All right, so that's the first number between 0 and 2 pi that works, approximately. All right, the second number that's going to work, all right, number 2, if x is positive, x is the first solution. So if this had been like tangent x equals positive 7 halves, then just arctangent would give me the first solution. Okay, and then I would add pi to get the second solution. Okay, so you'd still add pi if x was positive, but it would be the second solution. All right, so if x is positive, if x is negative. So that's kind of, they're both number 2. That is a solution if if that had been a positive number. If that negative 7, if that had been a positive number, this would be a positive number. And that would be your first solution, because it'd be between 0 and 2 pi. But when it's negative, you have to add pi to get your first solution. Right? If it was positive, you'd add pi to get your second solution. Right? But since it wasn't, the third thing we're going to do here is add pi again to get the second solution. All right, again, if that original x was negative. So you want to get two solutions. And you're going to add pi to get that second solution. It's just, did you have to add it the first time to get to the positives, and then add it a second time to get to a second solution, a second positive solution? Or was your first one positive and you just have to add pi one time? So it just depends on if you got a negative or positive first. Alright, so x2, the second solution in this case, is going to be approximately that negative 1.2925 that we got before, plus pi twice. Or we can just say plus 2 pi for that second one. Alright, and I'm going to stick I'll just write x2 is equal to x1, the first one, plus another pi. Alright, and we get 4.9907 roughly. So there's the two solutions in this case. So there's the first one, there's the second one. Alright, let's graph it on Desmos. Alright, once again, I've got the left-hand side of our equation. Alright, not the equals 0 part, but the left-hand side. I've got my x-axis with the wrench tool set to 0 to 2 pi. Alright, and now I'm going to click on the curve and just start clicking these zeros. So you can see there's the exact ones that we got. 3 pi over 4, the 7 pi over 4. Alright, there are those exact solutions. The not exact solutions, about 1.8491, there it is. The 4.9907, there it is. Alright, so it's rounding these to 3 places. So you're still, to get to the 4 places, you're still going to have to do all this work. You're still going to have to be able to do it so you can type in the expressions in here and get that many places of accuracy. But you can check it easily with Desmos. Just graph the thing and then find those x-intercepts.